Hello everyone. In last video we discussed about temperature versus volume diagram and the behavior of the vapor pressure with respect to saturation temperature and also discussed its behavior against moisture content. Today we will discuss the to finding out the other parameters using steam table. So as you can see the TS diagram and the bell shaped curve, as you know, this side is called as pure liquid region, this side is called as pure vapor region, and in between is the mixture region. So HF is the enthalpy of the pure liquid in kilojoule per kg. So at any given pressure, if you have to find the enthalpy of the pure liquid, simply look in HF column of steam table, and this is the Hg region. Sorry, this is the pure vapor region. And if you have to find the enthalpy at of the pure vapor at any given pressure, then simply look into Hg column of steam table, which is specific enthalpy of the pure vapor. It is also kilojoule per kg, but and this Hg is equal to Hf plus Hg. Hg enthalpy of the vapor, enthalpy of liquid, enthalpy of the mixture. But what if you have to find out enthalpy at point 1, suppose at this point in transition region where there exists some liquid and vapors mixture. So the formula is H1 is equal to HF plus X1 HFG1 at given pressure. Okay, you know what is HF, you know what is HFG. H1 is to be found out. Now talking about this X is called as dryness fraction, whose formula is mass of vapor upon total mass, means mg upon mf plus mg. It represents the percentage of the vapor in the total mass. So find the value of x, or it will be given in the numerical statement, and substitute all the values here from steam table, and hence you will get the value of h1 in kilojoule per kg. Exactly on the similar lines, finding out the entropy, S1 is equal to SF plus X1 SFG1. SF specific entropy of the pure liquid, SFG specific entropy of the mixture, X is the dryness fraction, and S1 is the entropy at this point, which is to be found out. Also, if you have to find the entropy at pure liquid point, simply look in SF. If you have to find specific entropy at this pure vapor region, simply look in Sg column in steam table, but in between this use this formula, S is equal to SF plus X SFG. Okay, now we have learned to find out enthalpy and entropy within this bell-shaped recurve region. What if you have to find the parameters beyond this line and beyond this line? The region beyond the pure liquid line is called as subcooled region, where the temperature is less than saturation temperature of the pure liquid, and the region beyond this curve is called as region of the pure vapor, where the temperature is more than saturation temperature of the pure vapor. Let us try to understand to find out the specific enthalpy and entropy of superheat region. But before that, let us discuss about dryness and wetness of steam. Steam is said to be completely dry when there is zero content of the liquid or moisture. That means mf is equal to 0. So in this region, at this line in the pure vapor region, dryness fraction is equal to 1. In this region of the pure liquid, where mg is 0, and there is only content of the mixture mf, so mf is equal to something and mg is 0, so dryness fraction will be 0. So in the region between these points, where whenever the dryness fraction is less than 1, that is in this region L plus V region, we call a steam to be wet steam. we call steam as wet steam, and at this line, when dryness is equal to 1, we call it as dry steam, and beyond this, we call superheated steam. Now we will try to understand to finding out enthalpy and entropy at these points. There are two methods for this. Either directly look into steam table or use the formula. The formula is H is equal to Hg plus Cpg into T soup minus T sat, where T sat is the saturation temperature at any given pressure. This will be given in steam table. T soup is the superheated temperature which is more than this T sat. It will be given in the numerical statement. Cpg is the specific heat of the pure vapor. Hg is the specific enthalpy of the dry vapor or dry steam, which will be given in the steam table. So using this formula, H is equal to Hg plus Cpg T soup minus T set, you will get specific enthalpy of the superheated region. Unit will be kilojoule per kg. Now to find entropy, S is equal to Sg plus Cpg into log to the base E of T soup by T sat. Now remember, the temperatures must be in Kelvin. Don't put in degree centigrade in case of entropy because it's the ratio of temperatures, and the conversion from Celsius to Kelvin involves addition of the constant. So difference will remain same like in this case, but ratio won't remain same. So it would affect your answer. So for safe side, always convert the temperatures into Kelvin. Now let us try to solve one example. So I have taken the condition of steam as 0.78, that is 78% dry, and at 1 bar. So H1 is equal to HF plus X HFG. HF is 417.5 kilojoule per kg and HFG is 2258 kilojoule per kg. 0.78 is assumed value of dryness fraction, and using this formula you will get H1 is equal to 2178.74 kilojoule per kg, means enthalpy at 0.1, means at this point. And exactly on similar lines, entropy S1 is equal to SF plus X SFG, where SF is 1.303 kilojoule per kg Kelvin at 1 bar pressure, and 6.057 is the value of SFG at 1 bar, and 0.78 is the dryness fraction. And solving this, I get S1 is equal to 6.027 kilojoule per kg per Kelvin. Now I have taken all these values from steam table. As you can see that at 1 bar pressure, at the pressure of say 1 bar, the value of HF value is 417.5, HFG 2258, and Hg 2676. And as you can see that our answer for enthalpy at point 1 is 2178.74, which is less than Hg. So for wet steam, the value of enthalpy at any point will be less than Hg. Now for specific entropy, look this point SF, pressure is 1 bar, pressure 1 bar pressure, and value of SF is 1.303. SFG's value is 6.057, and SG value means entropy of the pure vapor is 7.360. So it is, our answer was 6.027. It is less than SG, means the entropy's value is also less than the entropy of SG pure vapor for wet steam. Now up till now we saw finding the enthalpy of superheated and the wet steam. Now what if we have to find for subcooled region? This isn't asked in the examination, but just for sake of knowledge and understanding. H at H is the point in the subcooled region that is beyond the HF line. So is HF minus CPF into T sat minus T subcooled, where T sat is the saturation temperature, CPF is the specific heat of the liquid, HF specific enthalpy of the pure liquid, and hence in this way and T subcooled will be given which is less than T sat. This value will be given in the numerical statement. So H is equal to HF minus CPF into T sat minus T subcooled, and same for entropy is S is equal to SF minus CPF into log to the base E of T sat upon T subcooled. Also remember, always again remember that these temperatures must be in Kelvin to avoid the mistakes. So that's all in this video. So up till now we have learned how to draw a phase diagram, the temperature versus heat supply diagram, and also we have learned temperature versus volume graph, also behavior of the vapor pressure with moisture content and the saturation temperature. And today we discuss how to find the values from steam table of wet steam, dry steam, superheated steam and subcooled steam. So that's all from this properties of the pure substance. This chapter is now officially completed. So see you in the next video. Till then, like this video, share this video and subscribe to my channel. Thank you.